All right. Are your recordings posted? My recordings are always posted onto my YouTube channel. Not my personal one, but my school YouTube channel. And I think I did post it. I will double check after we're done here. So today we're going to be just doing some very basic graphing of trig functions. So I found this worksheet online. There was several. This one is the most basic one that I could find. I didn't want to overwhelm anyone, just getting the idea. It says using degrees, find the amplitude and the period of each function, then graph. So it wants us to find the amplitude and the period first, and then graph. So as a quick refresher, amplitude is referring to the height of the sine waves. Okay, so if we go to the amplitude of a sine wave, okay, you can see here the amplitude is the distance from the center to either the top end or to the bottom end. Okay, so the amplitude is not the entire height, but it is the height from the center to either end. Okay, the period is the horizontal distance between. Can I open this in a new tab? Well, that doesn't help. It is the horizontal distance between how long it takes the graph to repeat itself. So you can see that this would be the graph starting to go down, and then it goes up, and then at this point, right, it starts to begin the cycle again. So one cycle takes pi over 2. That would be the period here in this example. So amplitude, period. Here. So let's go ahead and find those things. So we can see from the equation here that since we're using degrees, we're going to be inputting certain degrees, but after we've inputted them, the sign will accept them and it will turn them into values. And then whatever those values are, that's the y equals that, right? There's not anything additional that happens. So as an example, it doesn't matter which numbers I put in here, like even if I put in 120, or even if I put in 30, sine will always accept whatever's here, and the sine function can only go as high as 1 or as low as -1. Okay, it's going to live between 1 and -1, regardless of what we put in. So the fact that this 3 is here is not actually changing the amplitude, because the 3 is part of the input of the sine. It's not affecting the sine after the fact. So sine is going to take whatever input, no matter how crazy, it'll take it as long as it's, you know, in the domain of sine, and then it will output a value from 1 to -1. And since there's nothing adjusting it after the fact, that tells us that the graph will be going between 1 and -1. So the center is here. That means our amplitude is 1. Okay, let me know in the chat if that made sense to you. Just a quick yes, it made sense, or no, please repeat or re-explain. Repeat, re-explain. Okay, there's a lot of repeats and re-explains. Okay. It's okay, so let's do some examples, okay? We have the sine of 3 times theta, like this. Oops. Okay, now this is a sort of a number sense thing that you need to develop, which is let's choose different values. Let's not worry about 3 times theta. Let's just say that it's going to be something, right? Whatever it is, 3 times theta will be something. Let's choose different degree values. So the logical place to start would be at the start, 0 degrees, right? Sine of 0 degrees, that would be 0. Okay, sine of, let's see how big we can get it. So sine of 30 degrees, we know that that's 1/2 from our common angles. Okay, sine of 60 degrees, or we can do sine of 45 degrees, right? Again, based on our common angles, we know that this is going to be the square root of 2/2. So slightly bigger than 1/2. Right? Sine of 60 degrees will be the square root of 3/2. Right? Sine of 90 degrees. I'm going to here do this a little faster. Sine of 90 degrees will be 1. Okay, and then based on the reflections and the fact that sine, remember, is part of a circle. So after we pass 90, it's going to start going down again. So sine of, let's say, 120, okay, that's going to be the same as sine of 60. So it'll be root 3/2. Okay, and it's going to cycle back and forth, and it's going to go 3/2, root 2/2, 1/2. It'll go back down to 0, right? Sine of 180 will equal 0 again. And then it will go through and it will do the negatives of those. Okay, and then the idea behind that is, again, has to do with, right? So as you rotate, your sine is getting bigger. At 90 degrees, it's as big as it's going to get. Keep rotating, right? At 180 degrees, it's 0 again. At 270 degrees, it will be -1. And then at 360, it'll be 0. So it's going to cycle through these values and all the values in between. Okay. Are we understanding that so far? Okay, lots of yeses in the chat. So based on that knowledge, the sine is going to go between, it'll start at 0, it'll go all the way up to 1, it'll go back to 0, it'll go to -1, and then so on and so forth, right? So it goes 0, 1, 0, -1, 0, 1, 0, right? And it'll just keep going the more degrees that you have. But it never goes higher than 1, and it never goes lower than -1. Okay? Now, how does this 3 come in, right? This 3, how does that affect it? Well, all it's doing is it's going to be changing the input of the sine. It's not actually changing the value that sine will put out. It is changing the value that is being put into the sine, right? Sine is still going to do its thing where it's going to output a value, and the output of sine can only ever be between 0 to 1 to 0 to -1, right? It's only in that, those are the numbers that sine can give. It can't give anything outside of that. So because of that, even though you're adjusting the input, what you're doing is you're just, like, if I put in a 10 for theta, right? If theta counts as 10, then really it's sine of 30, right? But sine of 30 is still going to be 1/2. Right? If I put in 30, then it'll just be sine of 90. Right? but it doesn't change the fact that its sign will still be limited between 1 and -1. Does that make sense so far? Okay. We're getting some yeses in the chat. All right. So we can think of this one, right? So sine is going to be bouncing between here and here. And let's zoom in even a little bit more, right? So sine is going to be kind of bouncing back and forth between these two. So let's come up with a more precise graph. Let's can I erase these? No. Okay. Now, something else that it asks us to find is the period. So we need to find the period, which is how long does it take the graph of sine to make one cycle? What is the time period of one cycle? So sine starts at 0, going back to that circle. It's going to start at 0, it goes to 1, then back to 0, then to -1, then back to 0. So how long does it take for a sine to cycle through all of these values? Well, that is where we need to take into account this 3. Now the 3 comes into play. So normally, sine takes 360 degrees to have its period, right? That's the period of its cycle, would be all 360 degrees. However, because we have this 3 here, any number that we choose for theta, for the angle, is going to be increased by 3. So let's take a look at the changes in the rate that we would normally choose. Okay, let's say that for theta, right, normally we would choose like some angles. Let's say we start with 0 degrees, and then we went to 1 degrees, and then we went to 2 degrees, and then we went to 3 degrees, and so on, right? Dot, dot, dot. We continued on that way. So by doing this, we're kind of imagining the sine, we're traveling in this direction, right? 1 degree at a time. That's what I'm representing here. Oops. So when you consider 3 theta, right? 0 is still 0, but now 1 is 3, right? 2 is 6, 3 is 9. Okay, if you look at this, you would say that this is increasing kind of 1 degree per step. I don't know, like 1 degree per time. Like that's a degree sign. 1 degree per step. This is going 3 degrees per step. So this one is cycling through all of the degrees 3 times as fast as this one. Does that make sense? Give me a yes or a no in there, that this one is cycling 3 times as fast as that one through the degrees. Okay, we're getting a lot of makes sense. Okay, so good. So if it's cycling 3 times as fast, right, it's reading through all the degrees, it's going through it 3 times as quickly, that means it will take 1/3 of the time. Right? So in the time where this one would take, like, to make 1, since this is going 3 times as fast, this one will already have made 3 turns. So the period of this guy will take 1/3 of the amount of time as this one. Let me know if that made sense. Yes, no in the chat. Okay, yes, so I'm getting a lot of yeses. Makes sense, okay. So normally the period, I say normally, right? If this 3 wasn't here, the period would be 360 degrees. Since this 3 is here, it's able to cycle 3 times the speed, which would mean it can cycle through it in 1/3 of the degrees, which is 120 degrees. Okay, so the period would be 120 degrees. Can you repeat the period again? Yes. So period is referencing how long it takes to cycle through all of the values of sine. Right? How long does it take for sine to complete one rotation, to complete one cycle? Normally, and when I say normally, I mean when it's not being adjusted, it is 360 degrees. Right? It takes sine 360 degrees to go through all of its values and then restart. However, because of this 3, the degrees are cycling 3 times as fast, which means it takes 1/3 of the degrees to cycle through all of sine. So instead of 360 degrees to being the amount of degrees, it's 1/3 of that, right, divided by 3, which is 120 degrees. So you divide by 3? Yes, that is correct. Okay, student says, so we would just divide 360 by the number in front of the 0 thing to get the period. Yes, so this 0 thing is, by the way, don't be caught out calling this a 0 thing, okay? It's called theta. It's a Greek letter. It makes the TH sound, right? And the letter is, it's used a lot in geometry to symbolize angles. So when you see this, this is theta. It's similar to x, except that we use it usually when you see a theta, you think, oh, that's an angle. Right? X is usually like, oh, that's an unknown number. Theta is like, oh, that's an unknown angle. Okay. So anyway. All right. So our period is 120 degrees because it's 1/3 of 360. So now let's graph this thing. Okay. If we put in 0 in here, 0 degrees, that will be sine of 0, which is 0. So we get this point. If we put in 30 degrees, okay, this is going to read as sine of 90 because it's 3 times 30. So at 30 degrees, this will be sine of 90, which is 1. So when we put in 30, we get out 1. So 30 is here, we're getting out 1. Okay. Now, when we put in 60, this is going to read as sine of 180 degrees because it'll be 3 times 60. So sine of 180 degrees is 0. So we're putting in 60. This is giving us 0 out. So we get a point there. When we put in 90, right, it's going to read as sine of 270. And sine of 270 is -1. So we're putting in 90 degrees, and it's going to give us out -1. When we put in 120, it'll read as sine of 360, and that'll be back to 0. So we have our graph here like this, okay? And that is one period. And then everything after that would be a repetition of this. So you can see it starts in the 0, it goes to 1, 0, -1, 0, and then we just repeat 0, 1, -1, like that. Repeat. So from here to here is one cycle. That's one period, right? And then you can see there's another one here from here to here, and there's another one here. All right. I'd like to pause now that we finished question 1 in case there's any lingering questions or lingering comments that I can answer. This doesn't seem too hard. Good. It shouldn't. This is, you know, it takes a little while to kind of get used to it, but once you get used to it, it should feel pretty simple. This is, we're just starting. Okay. It looks like there's no other comments. So let's go to question 2. Okay, now we're dealing with cosine, first of all, so let's notice that. And let's talk about the period and the amplitude here. So the period is once again going to be 1/3 of 360 degrees because of this 3. Right? So the angles, the degrees, the values of the degrees are cycling 3 times normal speed, which means this period will be 1/3 of the normal size, right? 1/3 of the normal equation. So we'll say, oh, let's do it as a text box. So the period is once again going to be 120 degrees. Now, the amplitude. So let's think about the amplitude in thinking about this 4, right? Cosine, just like sine, is limited between 1 and -1, okay? So when you think of cosine, again, we're thinking of this circle, okay? And cosine is the horizontal distance. Oh, that's the wrong thing. Cosine is the horizontal distance. So right here, cosine would be 1. I guess 3 is this way. Cosine would be 1 because it's in the positive direction and it's flat. And then as we turn, you can see down here along the bottom, this horizontal distance, it's getting shorter. So cosine is getting smaller and smaller and smaller and smaller. And then we reach 90 degrees and cosine is gone. It's 0 now. There is no horizontal distance here. So cosine is 0. And then we rotate and we can see cosine is once again getting larger, but it's getting larger in the negative direction. So cosine is negative. And now it's -1. And then it goes back, gets smaller. Cosine is 0. And then cosine is 1 again. Okay. So similar to sine, cosine is bouncing between 1 to 0 to -1 to 0 back to 1. You know, that's the sine starts at 0, cosine starts at 1 if you're starting at 0 degrees, but it's still bouncing between those similar values. So in a similar way as we said before, cosine is restricted to those values. However, because of this 4 that's here, let's say that we put in cosine of, let's say we put in a 0 here, right? We put in a 0. So this will read as cosine of 0, which we see here is 1, right? Cosine of 0 degrees, and that's 1. But this 4 now is going to multiply it, and it's going to stretch it out. It's going to make it bigger. So instead of being 1, it'll be up here at 4, right? Now, as we rotate the cosine, let's say we rotate it up to here. As we rotate, not the cosine, excuse me. As we rotate the angle up to here, the cosine is 0 now. So let's say that we put in, instead of putting in 0, let's say that we put into the cosine 30, right? So we put in 30, that's going to read as cosine of 90. Cosine of 90 is 0, right? This is 90 degrees. And you can see there's no cosine here. It's 0. So cosine of 90 is 0. And then you multiply that by 4, which is still 0. So we put in 30, and we're getting 0. Right? And then The same thing will happen when we put in 60. It'll count as 180. Cosine of 180 would be -1, which gets multiplied by 4, which counts as -4. So I guess the comparison here, I want you to look at a regular cosine and look at one that has the 4 in front and notice the difference. So a regular cosine, if it didn't have the 4, it would look like this, right? It would go to 0, go down to -1, go back up to 0, go back up to 1, right? And so that's kind of one period. And then it would go 0, -1, 0, 1. And then so on, right? 0, -1, 0, 1. Okay, this would be regular cosine if it didn't have the 4. Now that we have the 4, every time that it's reaching 1, it's at 4, and then it goes to 0, because 0 times 4 is still 0. And then it goes down here, and then it goes back to 0, and then it goes up here, and back to 0, and then here, and so on. Right? So this multiplication by 4 it's still following the pattern of when to go up and when to go down, but it's going up farther and down farther than before. So this is it with -4. So we would say the amplitude is 4. All right. Give me a yes or no if that is something that you understand. Okay, we got some make sense in there. All right. So good. I'm glad that you're understanding. So here's what I would like for you to do for tomorrow. Okay, what I would like for you to do is to complete these as best you can. The tangent ones we haven't really gone into. So I'm not expecting these tan ones, but at least the cosine and the sine ones you can complete. And then also on question 7, it says using radians. So you might have to go back to math 2 to remember all about radians. And don't, again, only worry about the sine and the cosine ones. We'll get to these other ones later. And then if you want to look at the answer key, it's posted as well. It's page 3 and 4. Okay, so that's going to be your homework. I would like for you to have it complete. That way we can talk about it going into tomorrow, and then we can proceed. Sound good? All right, let's end the recording.